So we have tan inverse of 3 on 4 for x to give us 36.8 degrees approximately. So this is the value of what? X. Then we still go back to the question. We are supposed to look at, that is 2. You know, the 2 was given in I and II. This is the II. II says we are supposed to solve for 1 plus cos x on 2 minus cos x. But the function that was given is if 4 tan x equals 3. So in this case, still going back, 4 tan x being equals to 3. That is what we are going to use to solve the second one. Then we will have our tan x to be equals to 3 on 4 as we had it at this point. Good. So if tan x is equal to 3 on 4, tan is 2, whereby we got in opposite and adjacent. Opposite and adjacent. Another way around, it is sine theta cos theta, but we are just going to go through it using the simplest approach. So once we have tan being 2, we just draw the right angle triangle again. Good. So we can just put x here. This is our x. So if here is our x, then our opposite will be here 3, and adjacent is here 4. Good. So let me give it liberation. A, B, and C. Good. So I have A, B, C. Good. So what we have now is, the moment you have such a question, it's advisable you find the longest distance so that you, based on that, to calculate what you are being asked. So based on this, I go by using the Pythagoras theorem. I know the longest distance, A, B, will be AC. That is the longest distance. It's AC, which is the hypotenuse. Because if you look at it, I've gotten the opposite, I've gotten adjacent. I need to get the hypotenuse. So the hypotenuse, which is AC, is equals to the root of 4, 3 squared, 4 squared, which is giving me AC to be equals to root of 25, which is equals to 5 units. So if that is the case, then what is going to be, let me bring the 5 unit down. Okay, so equals to 5 units. Good. So if that is the case, therefore, we can 1 plus cos x, 1 plus cos x on 2 minus cos x will be equals to, what is cos? Cos is adjacent hypotenuse. Now we know the hypotenuse to be 5. So adjacent, adjacent hypotenuse. So adjacent hypotenuse. So if we are going to have tan x to be 3 on 4, cos x, as you see, it is going to be what? 4 on 5. So I've gotten, in the first bracket, I've got 1 plus 4 on 5. 4 on 5 divided by 2 minus 4 on 5. Okay, so we solve these fractions simply. Okay, so I just have to create a space on my board to be able to work out here. Good. So we work the that aspect where we still continue by writing 1 plus cos x on 2 minus cos x to be equals to, just take it as a simple fraction. Every number is divided by 1. So the first aspect is 1 on 1 plus 4 on 5. Now divided by 2 on 1 minus 4 on 5. Just work it as a simple fraction. So what do we get? We have just using the normal multiple approach. So we got 5 times 1 giving me 5 here. Then plus 4 divided by 5. Divided by again 2, 5, 10. So 10 minus 4 also on 5. Okay. So the left hand side gives me 5 plus 4 give me 9 on 5. Divided by 6 on 5. So we apply reciprocal anytime there is equal to between two fractions. So we have our 9 on 5 times 5 on 6. Good. At this point, we cancel out like terms. Now 5 is common, 5 goes. Then 3 here, 2, 3 here, 3. So we conclude that, therefore, cos 1 plus cos x divided by 2 minus cos x equals to 3 on 2, or one whole number 1 on 2. So this one is the solution to the question. Now we move on and we go further by trying the applications of trig.